thank you for coming. It's plenty of you here. Oh, you can do that. All right, so today I will show you how you can simplify your Go project with domain-driven design. But at the beginning, a couple words about myself. So during the day, I work as a principal engineer in /ID, where we're creating identity stack for human and non-human identities. During the night, I'm co-founder of 3 Dots Labs, where we are teaching people how to write Go software maintainable in long term. Did maybe any of you had a chance to read at least one article on our blog? Okay, plenty of you. Hello, nice to have you here. All right, so as said, I'm interested in understanding how we can implement software more efficiently. So during more than 15 years, when I was working with software, most of the time I was hands-on engineer. I used to be also manager and founder. So I've seen problems of projects becoming developer nightmares from multiple angles. And one of the biggest problems that were slowing down us was complexity. But I'm not only saying about the accidental complexity created by over-engineering things. I'm also saying about the essential complexity, so the natural complexity of each feature that we need to support. Despite if we are thinking about some user-facing application or infrastructure application, you have multiple you have some set of constraints or invariants that you need to support. Starting with things like price cannot be negative, ending on regulations enforced by the law. The bad news is that if you ignore the essential complexity, we'll have even more accidental complexity. For example, let's take an example of complex financial application or complex e-commerce application. Trying to build this kind of application like a CRUD will generate a ton of accidental complexity. That's why this kind of applications tends to become legacy much faster than others. And let's now imagine a fictional company. It's named BillingMate. And I'm pretty sure that many of you will be able to relate to this company on multiple levels. So BillingMate is creating an API that you can use to issue invoices, take payments for those invoices. So in general, all the boring stuff that you not should be doing. And when they were starting 1 year ago, they were able to deliver new feature more or less weekly. But now, a year later, despite keeping code base in a pretty healthy state, they are struggling to deliver similar features in 1 week even. And it started to trigger a lot of awkward questions like, 1 year ago implementing such a feature took a week, now it's taking 2 months, what's happening? And I need to say, this question is very on the spot, because competition is not sleeping, and BillingMate have its competitor. It's Invoice Invader. An Invoice Invader is taking more and more of their customers. Why? Because they have more features. They are able to deliver more efficiently. So BillingMate have a problem. They need to solve it in some way. What's the most common solution in such problems? Let's hire more people. And that's what BillingMate did. They hired more people, then onboarded them, and surprise, they are delivering slower. So they needed to find another idea how they can improve situation. Fortunately, one of the people that were joining the company had a brilliant idea. And the idea was to, sorry, it's a PDF out of my laptop, but it's written here. It's because our application is monolith. We need to split that. It was the beginning of the project under cryptonym Migration to Microservices and Kubernetes. Probably I can spend another 3 hours on why it's not a trivial task and what can go wrong. Probably I should not do that. So let's just assume that they succeeded, they have dream Kubernetes cluster, and everything is great. Except one thing. They are still delivering software slowly. So BillingMate have a problem. Invoice Invader is taking more and more of their customers. They need to find some solution. Some people already started to say that I've seen it to be like that in every company that I worked. It's normal. And it's pretty convenient excuse, isn't it? But is it really true? And let's now meet Emily. So Emily joined the company recently, and she was not buying this message that it needs to be like that. And Emily started to do some investigation to understand why it's taking so slow to implement features. So she decided to see how it went to implement feature of credit note. Obviously, everybody knows here what credit note is. Okay, on their faces I see that note. No worries, I will just give you 1 minute free accounting course. So this is how invoice look like. So you can see things like who issued that, to whom, and you can see multiple invoice positions. Nothing really fancy, but as it sometimes happens, sometimes we have bugs. And in this particular scenario, we have invoice position for $90,000 instead of $9,000. Not best, so 10 times more. So let's imagine that it was bug on the production, and how you would fix that bug. We can update the invoice. No. Not in the financial world. It's not that simple in financial world. In financial world, when you issue an invoice, you can no longer and send it out, you can no longer modify that. But fortunately, accountants are pretty smart guys. And they figure out that they can create another type of document named credit note. And in this credit note, we can have negative positions. So we can have credit note with position for minus $81,000, and everything is solved. So this is the feature that Billing Mate was implementing. How the implementation went? So Emily found that it required effort of 3 teams, 7 microservices were changed. It took 3 months. The result, 2 PDFs. Pretty long, I would say. So Emily decided to do some kind of RCA process here to understand a bit deeper what went wrong here. So, okay, we cannot say much about the thing that we need to develop new features. I mean, our application is complex, but we cannot say, sorry, boss, we cannot add another features because our application is already too complex. It doesn't work like that. In best scenario, you need to, I don't know, somebody will ask you to go home, like Bill is doing, for example. Hiring new people, usually it's a good idea. So companies are hiring new people and able to deliver more. So probably it's not the problem. But I think the first place where Billing Mate did something wrong is how they are building microservices. So Emily noticed that Billing Mate took one of the worst possible approaches to microservices. So they took the old monolith application and they split it by database table. So each database was a separate service, and later assigned it to some artificial teams. Perfect idea. And this is how architecture of this looked like. So by yellow, it's yellow. By yellow, she marked all services that needed to be changed to implement credit note functionality. So you can see services like invoice positions, invoice printer, invoice audit, invoice validator, etc., etc. Let's wait for a second. Wasn't it one of the microservices goals to simplify things by splitting them into smaller? And that's true. But only as long as you're splitting things that are not coherent. If you try to split things that are closely related, like here, you'll end up with additional complexity. Do you remember this chart? It's exactly this thing. And it's visible in Billing Mate scenario, because implementing even simplest feature requires a lot of heroic effort to do that. So what's the solution in this scenario? I know that for some people it may be a bit controversial, but it's also kind of logical. So if we have things that are closely related, we should keep them closer. So in our scenario, the solution will be demicroservisation. So the opposite thing that many companies used to do earlier. So our architecture can look like that. So I'm not saying to kill all microservices, but we took all the invoices related services and we put them into one. And I know that for some people it's a bit controversial, but really, I did it multiple times. It saves projects sometimes, because again, it required a ton of heroic, unproductive effort of people to even create simplest features. So it really works. But there is one thing. So probably many of you are wondering that we had earlier multiple services and we merged it into one. And we need to have some way to manage the complexity of new service. And it's a time to give warm welcome to domain-driven design, often named as a DDD. So what DDD is? So my definition of DDD is that DDD is a set of techniques that helps to build complex systems that are maintainable in long term. So what does it mean? There are a couple things that we can take out of this definition. The first thing is that domain-driven design is not the right tool for simple projects. In other words, if you're creating simple CRUD application and you will try to use domain-driven design, accidental complexity. Don't do that. The second thing is that domain-driven design is not the best fit for proof of concept or throwaway projects. So for example, you know that this project will live for some quick spike that we need to check if something works. It's not the thing for DDD, because the initial investment that you will need to pay at the beginning will just not have enough time to pay back. And what's also unique for DDD is the fact that domain-driven design helps holistically. So domain-driven design, so many people think that domain-driven design is just about the code, but it's not the thing. Domain-driven design helps with code, but it can help you also with things like how to split microservices, how to build your architecture, but it can also help with some software things that are also very important, like how to gather your requirements, or for example, if you are solving the right problem, because you can write the best code, this is useless. So, you know, it's pointless that this is the best code. But we're on GopherCon. So I guess that we should be all interested mostly in code, in Go. So that's why I wanted to focus today on this part of domain-driven design related to the code. But I think after the presentation, you can also check other things. But to give you something useful from this presentation, I found the 3 patterns that you can implement in your project even tomorrow. So it shouldn't be something super complicated, and it should already help you with taking in mind for what kind of projects domain-driven design works. Let's not waste time, we don't have a lot of that. Let's go with the first pattern. And the first pattern is saying us to always keep valid state in memory. And this is a very simple but very powerful technique. I will show it to you by example. So this is how we can model simple invoice. So we can have number, we can have positions, we can have total amount, and we have also invoice position with product, quantity, value, and tax rate. And this is great, but it has one disadvantage, that you can artificially create invoice position that doesn't make any sense. So invoice position with invalid product, minus quantity, and minus value. So, you know, you're buying things, it doesn't make sense to have minus quantity. I don't want to guess how it will work under the hood and who paid that when value is negative. But let's leave that. The problem is that you can do that. And interesting thing is that it's not a problem in microservices. We may not think about that, but when we have microservices architecture, we have our API layer here. And usually on this layer, we have some kind of validation that is ensuring that we're not doing anything that is not allowed. But I found one very interesting old technique that allows us to do it without microservices, to ensure that nobody is able to do anything stupid with our code. I found it implemented for the first time 61 years ago, pretty long time ago, in programming language Simula. Yay. Maybe some of you even heard about this magic technique. And this is named encapsulation. Hooray. So how we can use that to ensure that our state in memory is always valid? So the first thing, we're putting our invoice struct to a separate package. It can be invoice, it can be domain, but it needs to be separate because we just made properties of the struct non-public, and encapsulation in Go is package wise. So everything in the package can modify that, but outside of the package, it's not possible. And later, we need to have constructor. By the way, I also removed the total amount from here because we can just have getter that is calculating total amount, so we don't need to care if it's updated all the time. Later, we need to create constructor for our invoice because we need to have some way to create new invoice. And in this constructor, we're ensuring that number is not empty, positions are not zero, not empty, non-zero, and that's it. Because it's one edge case when we can have kind of invalid state in memory. It can be zero value, because if you have any struct, you can always create zero value of that. So you need to keep it in mind. The same goes with invoice position. We're doing all validations to ensure that those invoice positions are valid, because those are the rules. For example, quantity needs to be greater than 0, and we're creating our invoice position. We need to modify our invoice. Perfect, we can have setter, but this is the only way to modify state of our invoice. Here, we are ensuring only that position is 0. It's not 0, sorry, but if it's not 0, we always know that it's valid, because the only way to create this invoice position is through constructor. And some of you may ask, how it helps actually? And it's not a big problem with when project is smaller, because you don't have a lot of people, you can track all the changes of the state. But the fun starts when you have bigger project, when multiple people are committing that, or project is older. And in this scenario, it's very, very useful to know that, okay, as long as I'm using public API, it's safe. It's like with microservices. You're using public API of the microservices, and okay, you can kind of assume that, okay, if you can do something, hopefully implementer of the microservice kind of protected you from all the bad things that you can do. And the same works here, but you don't need to have microservices for that. That's why it's that powerful. It's also much easier to test, because you don't need to, if everything, also if somebody's reviewing that, the person just see, okay, you're using public API, you're not changing, I know, invoice position by reflect. Okay, it's good, because you're not doing anything disallowed. So that was the first rule. The second rule is saying us to keep domain package database agnostic. So what does it mean? So let's take a look how usually our logic in application can look like when we are mixing domain logic with database logic. So usually in this scenario we have some database logic, domain logic, database logic, etc., etc., etc. And it's not a big issue if the application is simple. But again, we're talking here about more complex applications that we want to maintain in long term. And in this scenario, it's just super complicated. We can kind of say that code density is limited. So there's a limited amount of logic that you can fill in a limited amount of code. What's the solution here? It's also kind of obvious, because many things that I'm showing, it's not rocket science. If you think about that, there are obvious things, but sometimes we're not thinking about that. And the obvious thing is separating that. So we have our domain layer here, and we have our adapters layers. But, well, it's usually easier say to do than to do. But there's a simple solution for that. You've seen already how domain layer can look like, but how to deal with the adapters layer. And there's one wonderful pattern that I really like, and it's named repository pattern. And the repository pattern, in our domain package, we can define all the interactions from the database that we need. And thanks to that, we can separate this logic from our domain package. So we can have a method like create invoice draft and all the interactions here. And that's all. I wouldn't go into details how to implement that, because we don't have that much time today. But at the end of the presentations, I will give you some materials that you can use and see how you can implement it on real databases. And I think the next slide is the third rule. Actually, there are a bit older slides. So I will also show you that you can also pretty easily implement in-memory stuff. So it's pretty useful for unit testing things. So I know we have Docker containers there now, but if you have a lot of edge cases, it's faster to test things with in-memory implementation of your repository. So this is interesting bonus of that. And some people may also say that, okay, it's nice with repository pattern that we can swap databases. Yeah, it's kind of true that you can swap databases, but it's not something that you are often doing. Or if you are often doing, probably it's something wrong. But indeed, sometimes it's useful, but it's not a goal. It happened to me to do it multiple times, but it's not a goal. But from other side, it's a sign that, okay, if you're able to swap databases, you can, your database part, your domain part is database agnostic. Okay, and I guess the next slide will be the third technique. That it may be also obvious, but it's saying us to reflect your business logic literally in our code. So what does it mean? So let's take a look on a bit more complex invoice model. we can see multiple interesting fields here, like invoice number, invoice positions, but we can also see buyer, seller, issue date is issued. And the interesting thing about this model is that it may be even readable for a non-technical person. So you can sit with an accountant, for example, show it to this person with little explanation, I mean, what's tracked, for example, but everything else for this person, it will be very readable. It's because I use the same language that people from this domain are using. And again, I know that it may sound pretty obvious that, yeah, we should use the same language in the code than like other people are using. But from other side, for some magical reason, it's not happening. So try to think about all the scenarios when you were talking to somebody that is not a developer, and it took ages to figure out that, okay, you're naming this thing like that, we're naming it differently, but okay. And you're starting to do a lot of translation in your head to find the same language as that person. And I've seen it multiple times, and it's because this language may change with time, or maybe at the beginning we're doing proof of concept and we never have enough time to update this language. And it can be very beneficial, especially if more complex domain. When, for example, financial domain. When I was implementing something like that, I'm not an accountant, but I needed to ask some people how it really works. And if we're using the same language, it was much, much easier to communicate and implement that. For example, credit note. Credit note is a special type of invoice. Invoice position value can be positive and negative. Buyer and seller needs to be the same as the referenced invoice. And we can take those requirements, put directly to the code, and later ask our colleague from accountant part of our company. So buyer is buyer from referenced invoice. And yes, it's that. It happened to me even to sit with that person and ask, is it working like that? And yes, because it's kind of human readable. And this is all about this rule is about. All right. So I give you some simple techniques that I'm pretty sure that you can try to implement in your work really easily. But it doesn't mean yet, unfortunately, that you can put domain-driven design to your CV. As I said multiple times, it's just top of the iceberg of domain-driven design, and there are more things to learn. But it's good, because domain-driven design can offer us much more. But I will also give you some materials, as I said earlier. But before that, I wanted to play with you quick Mythbusters game. I'm not sure if the slide will be readable, because probably you didn't notice, but it's from PDF, not from my laptop, so the fancy animations are gone, and it's just a snapshot of the end of the slide. So I'm not sure how it will look like, but let's see. Yeah, some myths. It's fine here. Yeah, it should be animated. So please imagine that so the first myth is Go is a simple language. You should not use any complex patterns like DDD. Second one is domain-driven design makes code more complex, complicated, and harder to read. And the last one is saying Go is good language for business logic and DDD. And you can now imagine that this is now going from top, and I'm saying, they have one thing in common. They are generalizing heavily. Why? Because they can be both true and false, depending on what kind of project will use them. That's because I think we can update them a bit. So you already seen a bit of code that we use domain-driven design, so you should be able to help me with that. On the next slide, I have no animations, no worries, it will be good. So I think that the first one can go like that. Go is a simple language. You should not use you should use domain-driven design only for more complex projects. The thing that I mentioned multiple times, if you use it for CRUD applications, over-engineering, etc., all bad things, don't do that. I remember, so it will be like, please don't say later to your boss, Robert said to use DDD everywhere. No, 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 that's not what I'm saying. The second thing probably should be more domain-driven design makes code more complex and harder to read if you use it for simple domain. Again, for CRUD, some simple domains that there is not that much logic, it will overcomplicate that. But you've seen the snippets that I show you, and I hope that most of you will agree that it was pretty readable. And you can imagine how it will work for much more complex domains when it's 100 more times of use cases there, and it's really, really readable. If you imagine the code mixed with database, it will be totally unreadable. So that's my stance on that. And the last one, in my opinion, it's always false. So I totally not agree that Go is not a good language for business logic. So Go is my main language for 8 years. A big part of code that I written was domain logic and stuff related to that. I cannot imagine writing in any programming language. In my opinion, Go is just perfect for that. So in my opinion, this one is always false. All right, so what will be the next slide? Iceberg. So as said multiple times, domain-driven design is a wide set of techniques that can offer you a lot. So, things that I think sometimes we have problem with, how to split microservices, architecture, modularization. The strategic part of domain-driven design, so this is not related to the code, it's very, very helpful for that. But also this part, tactical part related to the code, we just touched this. So just the beginning. All right, what will be in the next slide? Yeah. So if you don't feel that you need domain-driven design yet, think about that twice. Because, okay, maybe you're not working with such projects yet, but you may, it may happen. So for example, you start some new part of your project that will require some more complex logic. And in this case, I think it's good to have in your toolbox the tool that you can use for this complex logic. Because if you try to oversimplify that, it will also lead to accidental complexity, as I said multiple times. So it's good to know that those techniques works. Maybe not go super deeply, but have more or less idea how to use them. And when you really need them, it will be helpful. It's also one interesting thing that I know that the job market is pretty tough now. But from the other side, hiring market is also not that nice. I mean, I was over a couple of years recruiting multiple people, and it's not easy to find people that are able to write complex code. I'm not saying complicated, complex. So, with big non-accidental complexity, essential complexity. And I think it's interesting skill to have, if you're looking for a job. And because, many people know how to create CRUD, but not a lot of people knows how to create complex code with complex domain. And usually these domains it's a lot of money, let's say, and people are just happy to pay you for solving their problems. This is the reality. All right, so the materials that I promised multiple times. So this is the QR code that you can scan, and it will give access to you to all those materials. It's also linked for this fully functional Go project that I mentioned. So you can run it locally and play with that, see how those patterns look in the real life. Because, I have just 25 minutes, so it's a bit a challenge to pack that. It have almost 5,000 stars, so maybe you can do it exactly 5,000. It will be nice. And I think that will be everything from my side. It should be QR code here. Okay, so that's everything from my side. Thank you very much for your attention.